I read somewhere once that all the major battles in history were fought at the intersection of two inaccurate maps. That kind of displays the frustration of reading maps under pressure. But one of the greatest innovations of the 20th century in my book is the establishment of a global positioning system. With this system and a receiver that you can get for as little as $100, you can plot your position anywhere on the globe, anywhere on Earth. You can come up with your precise position within a few feet. And I think that's pretty cool, especially if you're going to go hunting or hiking or be involved in search and rescue or law enforcement or whatever. Now, the problem with these little gizmos is much the same as it is with a lot of other stuff that's come out, like cameras and computers. They do so much that you get bogged down in the manual, and pretty soon you just give up and throw the thing in the glove compartment, batteries go dead, and it's worthless. But I'm going to show you how to take all the mystery out of this and show you what's important to know about your GPS and how to use it. Alright, let's review a little bit about what we know about the Earth. We've known for a long time that the Earth is not flat, it's a sphere. We also know that it rotates on its axis. That axis is, then it also revolves around the sun, and it's tilted on its axis a little bit with respect to the sun, and also that it has a magnetic field. So, if we draw our Earth here in 2 dimensions, the Earth is basically a sphere. It has an axis that it rotates on that's slightly tilted, and it rotates on that axis, and it has a magnetic field, something similar to that, which in the old days is how compasses work. So before we get into actually using the GPS, let's build a grid system for our Earth that we've got here. So we're going to draw another sphere. This time we're going to make the poles just go straight up and down for clarity. And we need to come up with a way to plot a position on the sphere. So the first thing we're going to do is we're going to draw a line of latitude right through the middle of it, just like you would slice an orange. And we're going to call that 0, or the equator. Then we're going to put other lines of latitude going all the way to the North Pole, equally spaced. So we'll draw another one here, like that. And notice that each one of these lines, more or less, is equally spaced all the way to the North Pole. Now, if you look at your GPS, and here's the most important thing. You need to find the screen that gives you your latitude and longitude. The numbers that look something like that. We're going to go ahead and copy those to our board over here. And these look strange, but don't give up. You're going to know exactly what these mean in a little bit. So we've got an N, 34, little tick mark there, 25, dot 430. And then the next line, we've got a W, 110, another tick mark, 35, dot 933. Alright, when we drew this first line, our latitude in the middle, more or less, we divided our sphere, or our ball, into 2 separate parts. So we're going to call this one up here the northern hemisphere, and then below the 0 line we're going to call that the southern hemisphere. So right away, looking at these numbers from your GPS, it's telling you what hemisphere you're in. Now, looking at the first number, we already know that we're somewhere up here. If it had a S, it would be somewhere down here. All right, back to the lines of latitude. So the next number might confuse you a little bit. You might have to watch the tape again to get a handle on it. But that's actually degrees, okay? So if we measure from the equator to the North Pole, we come up with 90 degrees. All right. If your GPS says anything more than 90, it's broke, because it only goes to 90. Now if we were in the southern hemisphere, the same thing would apply. It would be 90 degrees from the equator to the South Pole. So what this is telling us is that we're 34 degrees north of the equator. So if we cut that in half and said 45, then we're probably somewhere on a line down here somewhere. Now remember, that line goes all the way around the Earth. So if we're 34 degrees north, we're somewhere on that line of 34 degrees. Now, let's break this line of latitude up a little bit. See if we can pin it down a little bit more than that. All right, so we're going to draw a line of latitude. We'll just make it at the equator, or 0. And then we're going to go 1 degree north. And we'll signify that by putting that little marker there. Not 34 degrees, but we're just going to start out simple and go 1 degree north. Well, it just so happens that the distance of each degree of latitude equals 60 nautical miles. All right. So if I told you I was 1 degree north, you'd know that I was 60 nautical miles north of the equator. Now don't let nautical miles get y'all messed up. If you went 1 statute mile, you still got a little bit further to go a nautical mile. About another 1/10 mile. But it's still a mile. It's close enough for right now. So don't let statute and nautical get y'all messed up. Alright, so you know that I was somewhere in here. If I told you I was 1 degree north, I'd actually be up here somewhere. So let's pin it down a little bit further. We'll draw 2 degrees north up here. But I'm somewhere in here within 60 miles. Let's pin it down a little bit further than that. The next number is going to tell you how many minutes you are. So it goes degrees, minutes. So if this is 60 nautical miles, let's make it easy and make minutes equal 1 mile, 1 nautical mile. So we'd have 60 lines in here all the way up to 2 degrees north. So if I was 1 degree 30 minutes, I'd be halfway between, right in here. 60 minutes in an hour, pretty easy to do. So divisions of 60 and 60, degrees and minutes. All right, well, that's pretty cool. You would have me positioned to within a mile, and that's pretty good, but let's say we want to get even closer than that. Well, here we've got a 0.430. Now, you can make your GPS read in seconds or tenths of seconds or whatever, but usually they're set up like this. First of all, for our purposes, just forget the last 2 numbers. We're not surveying here, we're just trying to find somebody that's lost. So if each minute is a mile, this is tenths of miles, then if I told you I was 1 degree, 30 minutes, and 4/10, then I would be a little less than halfway between the next minute line, minute line. So now you got me down to within 1/10 of a mile. Hopefully you could hear me. If not, then you could use the other 2 numbers and narrow it down even more. So that's lines of latitude. Remember, it goes from 0 to 90 degrees. Can't go any further than that, because that's just as far as it goes. All right, so with this number to review, we know we're in the northern hemisphere up here, 34 degrees north, so probably on a line somewhere here, and we can break it down, get even closer than that. But where am I sideways on here? Well, that's what this other number does. Now, lines of longitude is a little bit more complicated, but still, we can get through this. What they did when they decided to make lines of longitude is, instead of going in equal slices all the way across, they decided to start at the pole and go to the other pole. Like this. Here's the North Pole, here's the South Pole. And what that causes to happen is that as you go around, the lines start to curve like this. So the only place that the lines of longitude are, and they're again in degrees, are equal distance, or 60 nautical miles apart, is right at the equator. Because as we get up here to the North Pole, they start to converge, and it's less than 60 miles from here to here. So don't let that throw you off too bad. But one of the big problems was, where do we draw the first one? It's not as easy as drawing the line perpendicular to the rotation of the axis at the equator. Where do we draw it? Well, they got involved in big arguments about that. And for a long time, people thought it should be Paris. Some people thought it should be London. People in Dallas, Texas think probably ought to run through there. Well, they finally settled that argument, and they decided to run the first line of longitude through Greenwich, England, where the Royal Observatory is. So that first line of longitude is 0. And what that does is that cuts the Earth into 2 more halves. Everything on this side is going to be west, and everything on this side is going to be east. All right, let's take a little bit closer look at these lines of longitude. In this particular case, we know we're in the western hemisphere, or west of Greenwich, England. As a matter of fact, we're 110 degrees west. So here's a 110 degree west line right here, and as you go from right to left, the numbers get bigger. And we're 110 degrees, 35 minutes. Alright, so if we make this line 110 to 111 degrees, then 35 minutes is going to be 30 minutes would be halfway, and 35 minutes would probably be right in here somewhere. We've already plotted our line of latitude, so that is where I am. If I had an emergency and I had those 2 numbers and was able to communicate with some kind of search and rescue operation or law enforcement facility, as long as they knew what they were doing, they could come right to me. Certainly a helicopter pilot would understand what those numbers mean, and he could bring a copter right in there and pick me up. You know, they got a lot of these survivor shows and all this kind of crap on TV nowadays. As long as you've got 2 things, there's no need to ever subject yourself to any kind of survival situation for more than 24 hours anyway, if they can get a helicopter in there. If you've got a satellite phone, a cell phone, ham radio, walkie-talkie, whatever, that you're able to communicate with somebody else, and you can get the dispatcher those 2 numbers, they got you. You're good. Now, I don't know if 911 operators are trained in trying to recognize this. You know, you may have to get a little gruff with them and make them shut up long enough to let you talk, tell them where you are. But anybody with any experience at all is going to know what those 2 numbers mean, and they're going to come right to you. Several years ago, we had a friend wreck his motorcycle out in the wash over here, and we went up and found him with the airplanes. But the terrain was too rough, we couldn't land. So I got on the radio and the emergency frequency, got a hold of a commuter flight from Phoenix to LA that was monitoring the emergency channel. Gave him those two numbers, and that evac helicopter landed in my lap. I was still circling above, but he came right to the accident site. And no more of this, you know, go down to the water tank by the cattle guard and turn left at Fred's place and go down another 2 miles till you see the bend in the road, and you know, that kind of thing. With these two numbers, they can come and get you right away. Same thing, if you got a GPS and somebody gives you those two numbers, you can put that in as a waypoint, and your GPS knows where you are. It knows where the trouble is. It's going to point to it and give you a distance, so you can go right to somebody that's hurt. Or if you're hunting and you nail an elk or deer or whatever, and out in the woods and you're afraid you can't find him, make a waypoint out of that position, and you can go right back to it. All right, now, if you were to call a helicopter or law enforcement or dispatcher at 911 or whatever, and you're going to give her these numbers, the proper way to do it is to read it off just like we learned. You would tell them I'm at north 34 degrees, 25 minutes, 0.430. West 110 degrees, 35 minutes, 0.9. If you can't remember that, just remember to split the numbers up. 34, 25, 430, 110, 35.9. And it should get you. Now let's put that into practical application. Enough of globes and all that kind of stuff. Let's say that I had a secret spot that I was going to meet you at, and we were going to go do some treasure hunting or metal detecting, or whatever you want to call it. And that spot was north 34 degrees, 23 minutes, 5/10. And it was west 110 degrees, 39 minutes, and 8/10. Well, you could put that into the GPS and make a waypoint, but we want to see where that is. And the GPS is only part of the equation here. You need a good map. Most national forest maps nowadays and the good hiking maps are going to have latitude and longitude on them. So here we go. Let's say we're 34 degrees north, all right, on my map right here that I've laminated of the local area that I copied off of National Geographic software. There's 34 degrees, 24 minutes. Oh, so 23 minutes. Sorry. All right, so there's 34 degrees and 23 minutes right there. And I said we're 0.5. So there's 34.23. There's 34.24. So we're on a line there somewhere in the middle. All right, the next number was 110.39. So that line is right there, but 110.39.8. So 110.39, 110.40 is right here. So I'm right there, and that's it. I like to laminate these things because we go out in the weather a lot of times and they get wet or whatever, and you can use a marker to mark on it, and when you're done with it, you just find your rag, wipe it off, and you're good to go again. Now there's a lot of other things ways you can use the GPS. One of the most useful functions is what they call the track back function. Not all GPSs have that. Usually the hiking ones do. Ones in the cars, not so much. But even the ones in the cars, you should be able to find a screen that's going to give you those two numbers. And if you've got that, and you've either got another GPS to go to a waypoint, or you've got a good map where you can figure out how to get there, then that's it. You got it. You know where you're at. You know where somebody else is at. You know how to find them. So don't let the whole latitude, longitude thing mess you up, confuse you, and give up, because believe me, this has come to my aid more than once, and to the aid of other people even more than that. We got in a hunting situation one time where the guys were mountain lion hunting, and they didn't know where they were. And I noticed that one of them put a GPS in his backpack before he left the truck. I was able to get a hold of him, and here's the key: we were able to communicate with them. They had walkie-talkies. And it started snowing, coming to blizzard, and we wanted to retrieve those guys as quickly as possible because it was getting cold, and they'd already hiked about 10 miles up and down these steep canyons. So I got him to read me off those 2 numbers, and then I put those in my GPS, and I knew where he was. So we could take the truck and come to an extraction point and basically tell them where we were, and we recovered them in short order. So they would have made it anyway, but it was kind of nice for them to pop out of that canyon, and there was a nice warm truck sitting there waiting on them. So that's it. Hope you play with this a little bit, and believe me, you'll be the cool dude when everything goes to hell and nobody knows what to do if you understand how to use these numbers and how to put them in your GPS and how to figure out where you are, where somebody else is. So enough of all that. See you later. Oh, I almost forgot. To give you an idea how useful these things can be, this here is Scout the Wonder Dog, and he's got a nose on him that you just wouldn't believe it. Sometimes that nose gets him in trouble. He'll launch off after an elk or a deer, and he's gone for hours. I mean, 8 to 10 hours. I lost him in a blizzard once. So I got tired of this emotional roller coaster of losing my dog and all that. So I bit the bullet, and Scout's got his own GPS. So about every 4 or 5 seconds, his position is being sent to this little device here, and it tells me where he's at. And right now, it says Scout's near, because he's right there. But his collar is taking signals from the satellites in outer space, figuring out where he is. This knows where I am. It can compute a straight line distance between me and the dog, and I know where he is, so I can beep him with a button here, and he'll come right to me, usually. If he doesn't, then I give him a little shock, and if that doesn't squirm away, then I gotta load up in the Ranger and go get him. But keeps me from losing my dog. So there's all kinds of things you can use GPS for, and if you play with it a little bit, I think you'll really enjoy messing around with it. That's it.